All right, but today we're looking at adding and subtracting radicals. Pretty much what you saw in that Ed puzzle video. So if those questions were making sense or you were able to follow his work, that's kind of what we're doing today. So I just wanted to make sure we had a chance to kind of look at it together and make sure we have it down. But the steps you kind of want to do, and I mean, I kind of just made these steps up myself. I don't know if this is the most proper way to think of it, but the first thing you want to do is always check if you have like radicands. And if you remember from the Ed puzzle, or if you haven't had a chance to watch it yet, a radicand is just the number underneath the radical. So like X would be my radicand there. So because the reason is if you have like radicands, then you can just add or subtract right away. But if you have different numbers underneath your roots, then you're going to want to simplify your radicands. You're going to do your factor trees, break them down, because a lot of times when you break them down, you'll see once you've done that, they are like radicands. So step 3, if it's possible, add or subtract like radicands. So I guess I should have put subtract as well, depending on the problem. You're not always going to add. But that's kind of the process. But I think honestly, the easiest way with anything is just to see it kind of worked out in examples. So I'd highly encourage if you got a notebook or you got some paper, you follow along with these questions, because you really learn best by doing. And that's true with anything, not just math. I mean, if you want to learn how to do something well, I mean, honestly, the best way is to kind of go out and try it and do it yourself kind of thing. So looking at this first example, like I said, the first thing you always want to check, and let's see, let me zoom in just a little bit, is check your radical part. And you want to look at those numbers underneath. Are they the same? In this problem, yes, they are. We have the square root of 6 and we have the square root of 6. So the radicands, or the numbers underneath, are the same. So you can add these together. How you want to think about it is you have 7 of these radical 6s plus 2 of these radical 6s. So if you add the outside numbers, that would be 9 radical 6. So if you have 7 of those plus 2 of those, you have 9 of those. That's kind of the idea. First example. So if you have like radicands, makes it very simple. How about you guys try number 2? Just be careful if there's no coefficient. Remember, this means you really have 1 square root of 13 plus 5 square roots of 13. So since you have a like radicand, what would this problem equal? So if you want to give this one a try, that should be a quick one. So like I said, if you have 1 of these plus 5 of these, that would be, you add these like outside coefficients, so that would be 6 square root of 13. So you should notice when you're adding or subtracting like your radical part, like the square root part doesn't change. It's just like your coefficients that you're really adding or subtracting. But that's how you really want to think of it. Like how many of these plus how many of these equals how many, like don't even really pay attention to the root part necessarily too much, as long as they're the same. I mean, obviously that is crucial, but if they are the same, then you can just basically combine them just like you would a variable. Like, so that's really like 1x plus 5x would be 6x, or 6 square root of 13. But let's look at some problems where we got a little bit more work. So like, for example, in problem 3, we're going to see we don't have the same radicand. So this doesn't mean necessarily we can't add or subtract. We just need to try and simplify these down, because there's a lot of times when you simplify radicals, like you'll see you end up with the same base radicand. So it might not look possible at first, but once you clean it up a little bit, you should see. So I'm just going to do a factor tree for my 32. So you'd want to figure out 2 numbers that multiply to 32. So you can always do 2 if it's an even number. So we could do 2 and 16. You could have done 8 and 4. Maybe there's other ones I'm missing. But that would be 8 and 2, 4 and 2, 2 and 2. So I like to always cross out the numbers that I broke down so I don't actually include them. But if we write what we have, so this is kind of how he wrote it in the video, we have 1, 2, 3, 4, 5 2s. So if you look, since all these problems today too are going to be square roots, so we're circling groups of 2, but we can make 2 groups of 2. So I already started with a 6 on the outside. I'm going to pull out a 2 from this first pair. And I'm going to pull out another 2 from this second pair. So if I multiply that together, I'd have 6 times 2 times 2. That would be 12. Times 2 would be 24. And then the only thing left behind was this 2. So it'll be 24 square root of 2. And then we're going to do this second part. But there's nothing I can't break down the 2. And honestly, I mean, you might already see it's already a like radicand, so I wouldn't really want to break it down anyways. But this would be, so I'm just going to copy this other part, and sorry for the different colors. I didn't really mean to switch on you. But so now this is like a problem we saw in number 1 and number 2. We have the same radicand, so we can add or subtract these. So in this case, we're subtracting. So you subtract 24 minus 5. That would be 19. The radical, we don't change. So that's the big idea. I mean, just kind of using some of those skills we saw last week with simplifying, and hopefully those are getting a lot better. I mean, we've been doing it in a lot of problems, so that should be something we're a little bit more comfortable with. But basically, we just need to simplify, then we turn it into a problem like 1 and 2. So how about you guys see if you can do number 4? So for this question, you're actually going to want to do a factor tree for both parts. Like write your new answers and then see if you can combine them. But I'll give you a second if you want to get this one to go. You guys, but let's go over this one. Let's just see how we're doing with it. So if you break down this first factor tree, I mean, if you were doing it, it could look different. But I don't know. The first thing I thought of for 24 was 6 and 4. But certainly there's more than that. It's a possibility. So 6 would be 3 times 2. 4 would be 2 times 2. So if we cross out what we broke down, the numbers we have 3 2s and 1 3. So we're circling pairs, so we can only make a pair of 2s. So I'm going to write like this first part in purple. So if I do that, I would pull a 2 out from that pair. And then what was left behind was a 2 and a 3. So if you multiply 2 times 3, that would be 6 underneath your radical. So then we're going to do our second factor tree, or maybe first off, it's going to be minus whatever we get. What is it? Keep doing that today. Sorry, it wasn't right in it. Turn it on and off. It seems like it fixes it. I don't know why though. But if you break this down, I mean, the first thing I see for 54 is 9 and 6. I mean, you could have done 2 and 27. I mean, but as long as you break it down, you'll get the same thing. But this would be 3 and 3. This would be 3 times 2. So if we write what we have 3 3s and 1 2. Okay. Why it keeps. But if you circle your groups, you got 1 3 is going to come to the outside. And same idea, you have a 3 and a 2 left over. So underneath your radical would be a 6. So since we do have like radicands, we can subtract these. So 2 minus 3, you remember you subtract the coefficient. So 2 minus 3 would be -1. And then your radicand or your radical part stays the same. So -1 square root of 6 would be your final answer. But if you were on, like, I don't know if not many people submitted their answers, but if you got the answer for this number 4, or at least you were close on the right track, I mean, that's a good sign. Like I said, number 4 is a good one. If you can do a question like number 4, I think there's a good chance you can pretty much do anything that's going to be thrown at you. Okay, so sorry, I was just trying to clean my screen, so sorry if it scoot up there. Let's look at another one together, and then maybe I'll have you try one before you head out here. So for number 5, I'm honestly, if you look at what we just did in number 3, we're going to do the same factor tree. So, I mean, if you ever catch this, like you've already done a factor tree for a problem, I mean, if you don't want to break it down, you could just look at what numbers we got. Like when I broke down 32, I got 4 2s or 5 2s actually. So if you ever see you already broke down a number, like you're doing a bunch of problems, I mean, if you already have it worked out, why do it twice? You know what I mean? So we have 2 pairs of 2s and a 2 left over. So if I rewrite the square root of 32, that's going to be 2 times 2, or 4 on the outside. And then the only thing left over was 1, 2. And then the 3 square root of 2, you can't break that down. So it's just going to stay the same. So we can add these because they have like radicands. So that would be 7 square root of 2. But that's one thing, especially if you're doing a bunch of problems, always look out for if there's like a tree or like something you already broke down, because I mean, if you already did it once, you don't have to do it twice kind of thing. So that's something that can save you time when you're working on problems. So, but that's the only case I think on this sheet, like 32 and 32. I think all the other numbers are different. It looks like 6 and 8 share 27. So there are some duplicates. So like I said, if you see a duplicate, use it. I'm going to do one more together, and then maybe I'll have you try here. Maybe I'm going to skip 6 actually. No, I'll do it just to show you. I mean, the variables we're going to see don't really do anything, but so this one you would have, you break down your 27, that would be 9 times 3 or 3 times 3. So, I mean, we really have 3 3s and an x if you want to bring down the x, but we're going to see the x can't make a pair, so basically it just stays underneath. But since we already had a 2 on the outside, this would equal 2 times 3 is 6. And then the things left over, we had a 3 and an x left over. So that's what this first part would turn into. So then we're going to have minus. Maybe I'll do the second part in a different color. We'll do it in green. So if you break down 48, you could do 12 and 4. You could do 2 and 24. But I'll do this. But 12 would be 6 and 2. 6 would be 3 and 2. So if we look at what we got, we've got a 3. We've got 4 2s. And we've got that x from above. So if we circle any pairs, we can make 2 pairs of 2. So when I already have a 3 on the outside, so 3 times 2 would be 6, times 2 would be 12. And then the only things left over are a 3 and an x. But you'll see these radicands are the same. So don't treat it just because you got a variable any different. That would just be 6 minus 12. That would be negative 6 square root of 3x. So even if you see x's, I mean, if you can pull out a pair, you can pull an x to the outside, but for a question like that, it doesn't affect anything. I'm going to do one more, and then I'm going to let you guys try 8 if you'd like to see if you can handle something like that. But for 7, we just got to break down, even though we have 3 parts, I mean, just treat it the same way. We're just going to break down each part on its own. I mean, this part doesn't break down. So really only we got to break down 24 really quick. So that's 6 and 4, or you could do any combination. But if you look, you have 3 2s and a 3. So you could circle a 2 and just be mindful of this negative 1 that's in front. So when you rewrite this, this would be negative 2 when you multiply those together. Square root of 6, because 2 times 3. For this one, you have 4 and 2, which would be 2 and 2. So you really have 3 2s, so you can make a pair of 2s. So 5 times 2 would be 10. And then the only thing left over was a 2. And then this part doesn't simplify. But one thing you're going to notice in this problem, see how all the radicands are different? That means you can't combine them. So if you ever have a situation like that, just stop, circle your answer. I mean, just double check maybe that you simplified them all the way, but like 6 you can't break down, 2 you can't break down, 5 you can't break down, like to pull out any pairs. So If you ever end up with the situation where your radicands are different, just don't circle them. You can't combine them. Only if they have the same number underneath can you add or subtract. We'll see it's a little bit different when we get into multiplication. But with addition subtraction, they have to have that same number. So if you'd like to try number 8 on your own, that will be our final problem for